went into consultancy in pumping systems efficiency for a few years. And then the Internet of Things came along. I was working in the telecom sector, and I realized this was the technology which was going to transform the way we ran the water sector. So I started a small company called Aquamatics in 2011 to pioneer the introduction of IoT into the water space. 8 years on, we're still a very small company. Of course, we've pivoted the company and redeveloped the platform now 3 times. And so we're just in the process of pivoting again into a very exciting development, I hope, which will hopefully be the proverbial hockey stick, but we'll see. So anyway, nice to be here. I'm a long-standing, been in water all my career, and it's been a long one.
Welcome. And Laurie, will you please hand it off to the person on your right?
I do beg your pardon. Yes, it's Ramzi on my right. In fact, is that my right on the screen or my right on the physical? Because it's this side, isn't it? So it's that way. That's
Yes.
Ramzi's over there.
Okay, it's okay. Hi, everybody. My name is Ramzi Bouzerda. I'm CEO of Droople. Actually, I'm not really a water expert, or because I'm in the water field since more than 2 years now, and I'm born in a country where water is scarce. I'm coming from Algeria, and I grown up in Switzerland. And actually, I really lived what it means no water security, because we were limited, we were under drought, and then we were also facing low pressure in the water pipes, meaning that we were living at the 11th floor of a building, and where water pressure was not high enough to bring that water at the 11th floor. And every 2 or 3 days, we had to go down, because the lift was not working, of course, to fill the tanks and to secure water for the next days. So I lived that until 6 years old, and I remember my mother and my grandmother filling those tanks. And for me, it was a signal that if you don't have water, you have serious problems. And when I came to Switzerland, beautiful country with plenty of water, I felt very relieved and yeah, gifted to turn the tap on and get fresh and safe water. So that's my background, and I'm very happy to meet you all and share with you this great topic.
You know, say a little bit about your current platform, Ramzi, because I think that's important too.
Yes. So Droople is a full stack solution to monitor and predict the maintenance and reduce water and energy waste of water assets, meaning water treatment systems, sanitary ware, and appliances. We have combined pressure, flow, temperature, and other metrics like TDS and pH, where those sensing capabilities work seamlessly with our cloud solution. And we actually have developed different modules for filtration, for sanitation, and for water monitoring in a larger sense. That's it.
Thank you so much, Ramzi.
Thank you.
Go ahead and hand it off to the person on your right.
Yes, sorry. So I go back to Susan on my right, or yeah.
And if it's someone who's already introduced themselves.
Sorry. So I go to Helena. Hi, Helena.
Hello. Hi, I'm Helena Rodriguez. I'm the water engineering director here in Indar. Indar is a company, and the business unit where I work, we manufacture submersible pumps. My background is in mechanical, hydraulic engineering. I started in the pump industry 23 years ago when I was still in the university. So long way designing pumps, reviewing projects, and trying to support in the water industry also sharing knowledge when I can. Sometimes I support also the university here in North Spain, the Master in Mechanical Engineering, in the part of designing pumps with different software.
You are the master of pumps. Yes, now I recognize you.
Yeah, I'm quite active in LinkedIn, trying to post different topics of pump design and hydraulics. I know that is for young engineers is not a very attractive market. Looks like they don't really like pumps and water industry. So I try to post this area of the engineering very positive and like challenging for young engineers coming to this industry.
I think the problem, Helena, I'm seeing is not that people are afraid of pumps or don't like pumps. It's just they don't understand because they don't have any kind of engineering background. The contrast in my career, spanning some 40 plus years, when I joined the industry, there were many engineers, very professional, highly qualified engineers. I would say 30% of the industry had a technical background, and the majority of those were engineers. Now here in the UK, everybody's talking about customer service and about marketing and about and HR and people. And actually, that balance has changed, I think, detrimentally. And now it's very difficult to even explain to somebody basic hydraulics, and the system curve of a pump is something which is very
even in people learning and in the Master of Mechanical Engineering, they are really focused on things like marketing and MBA after the master. So they don't really think themselves working in the pump industry. Mm-hmm. I recognize that I started in the pump industry and the water industry just by coincidence. I was in the 5th year of mechanical engineering, and there was a pump company in my hometown. I just wanted to make something during the summer related with my studies. Like, this was a pump company, so I applied for working there like internal engineer, young engineer during the last 2 years. So I just started by coincidence, and I have realized that I really love this topic.
Helena, thank you so much. Let's go ahead and pass it off to the person on your right.
Yeah, on my right is Susan again. So I think let's go to John.
Hello, I'm here as a neophyte in the water industry. I started with a initial entry with a small city outside of Philadelphia, and that's where I know Susan from. And I worked with Howard Newkirk, who is the chief of water supply for the city of Philadelphia and is on the faculty at UPenn. And we designed a water monitoring system to detect contaminants. And I went through a customer discovery process in the I-Core program at Penn. That's sponsored by the National Science Foundation, and it boosts startups and gets them off the ground. And we first thought, well, we would look at ocean contaminants, and but after reaching out to various departments of health, we determined that our best market would be with water relief in disaster and emergencies. And the idea was to put nanotechnology sensors on the entry to the pump, and then the water would be cleaned, and then we'd monitor it when it went out. But the costs were very high for the nanotechnology manufacturing, and the device is still waiting to be developed.
Thank you so much, John. And it looks like, Deborah, you're gonna take it home for us before we jump into the rest of our agenda.
Hello, I'm Deborah McKay. I'm the Senior Administrator of Product Compliance for Fortune Brands Global Plumbing Group. I have that is a group of plumbing companies. We used to be, most of my time is with Moen, and then Fortune Brands has purchased Roll, Riabel, Perrin and Rowe, Shaw's. I think that's everybody we have, or Victoria and Albert. So I work across all of those companies with their global compliance. And my involvement has mostly been with the code agencies, IATMO, PMI, NSF. So this is a new experience for me with this group.
Thank you so much, Deborah.
And I'm near Cleveland.
That was going to be my question for you. So we know, yeah, the state of light in the area where you are. Great, thank you. Well, with that, let's head back over to Ramzi and Susan. And maybe each of you could take, I'm looking at our time here, 5 to 10 minutes somewhere in there and really kind of delve into your work, your products, the impact, really tying it back to this efficient one water approach.
Yeah. Susan?
You want me to go first?
Yes, of course.
All right, let me share my screen here. Okay, everybody can see that? So H2O Connected is, it's actually a company that's a divestiture from End Solutions, which is a company I co-founded in 2006. End Solutions is a product development company, and we take technologies from concept to revenue in areas that save lives, save money, and preserve natural resources. So one of the technologies we developed was a multi-patented technology that detects every type of water loss problem that occurs in a tank toilet. And when we decided to take that technology wireless for the multifamily, student housing, hospitality customer, we decided to spin it off into a separate entity, which we did a couple of years ago, and then developed the technology. Let me just see, there we go. Just to give you just some statistics behind the problem we're trying to solve. In the United States and Canada, there's 350 million tank toilets. There's over a billion internationally. I don't know how they came up with that number, but that's as close as I could get to a statistic. Toilets are the #1 cause of a high water bill or a saturated septic system, or a dry well if you're living out in a rural area. And we've clocked, I think the EPA says that 20% of all tank toilets are leaking at any one time in the United States at a rate of about between 100 and 200 gallons per day. And our technology has validated this. In fact, it's probably more than 20%. And we've actually clocked toilets with leaking flappers over 400 gallons a day in some instances. But the real elephant in the room is a running toilet. An undetected running toilet can waste up between 4.5 and 5.5 gallons per minute for someone that's on public water because of the water pressure. So that equates to over 7,200 gallons per day, and it usually costs about $100 a day on average. So in addition, you have toilet overflows, which can cause black mold. Because it's a biohazard, the remediation cost can be north of $40,000 per incident. You've also got overflowing, and problem toilets are usually repeat offenders. So if it happens once, you're likely going to have a repeat problem. So it's really a real issue, and there has not been a real consistent, reliable, cost-effective way to address this problem. In addition, a lot of times you may say, well, you can hear a toilet that's leaking. Yes, but some homeowners are hard of hearing. You have guests and property owners that won't report the problem to the management, or they don't understand what the symptoms are for a leaking toilet because there's not water on the floor, and therefore the problem continues. So the original technology we developed was non-wireless, but it installs in seconds and hangs on the wall of your toilet tank. And basically it's got sensors that go in the water. You lift up the tank, you hang the device on the toilet so that the alert system is on the outside, sensors are on the inside. You put the toilet lid back on, you flush the toilet, that's it, you're done. So it literally installs in 10 seconds. It works mostly just about any tank toilet. There's 6 patents and dozens of trade secrets that are involved in the technology. And it will, when you flush the toilet, it knows somebody's in the bathroom. And so if the toilet's functioning properly, it will flash green. And if there's a problem, it will flash red and beep during the flush cycle. And depending on how it flashes and beeps, it'll actually tell you whether the problem's the flapper, whether it's going to run, whether it's going to overflow, or whether it's a fill valve. And this device, actually, we've sold tens of thousands of these, and it sells on Amazon. And so that what we decided to do first is to really prove out the leak detection technology through a homeowner version first. We got a lot of requests for a wireless version. So enter the Leakalertor Pro. And this takes the Leakalertor 6000 technology to sort of an advanced level. It's a totally in-tank system that's wireless. The install, again, takes seconds to install. You lift up the tank lid, you hang it on the back of the toilet tank, you close the tank lid, you flush the toilet, you're done. So this is important for property management where they've got maintenance people, because we designed this so it didn't run up the cost of your maintenance either on install or on operation. Once it's installed, it wakes up, it knows it's in water, it wakes up and it goes to find the gateway. And we have developed a proprietary gateway that connects to our Leakalertor Pro nodes in the toilet through LoRa. And then it sends the data through the gateway that then goes through AWS Core to a dashboard that's available to the property owner and to us. When the device detects a number of problems, leaking flapper, leaking a faulty fill valve, water going down the overflow tube, equilibrium, which is the fill valve and the flapper leaking at the same rate, running toilet, overflowing toilets, all kinds of issues. If it's the priority events, they'll send a text message to maintenance personnel so they know where the problem is located, what the severity of the problem is, and what exactly needs to be fixed so they can repair it. There's also, for lesser issues, we send emails, and also all the alerts go in on a dashboard. So it enables the property management to be able to quantify its water loss through toilets, but also they can group the repairs and efficiently manage their toilet water usage. This is what the device looks like. You can see it hangs on the back of the toilet, stalls in seconds. The battery life, there's an internal replaceable battery. We estimate the battery life will go for 7 or 8 years. We guarantee it for 5. Same with the system. We found that people are getting positive rates of return within a 6-month period. So just to I wanted to give you an example of a field test. This is with a hotel that has 108 rooms. We installed, this was in the beginning, about a year ago. We installed 97 Leakalertor Pros. The hotel had been fully renovated with new toilets and new toilet components in 2018. So at the end of 2019, when we started testing, we really didn't expect to find that many issues with their toilets, but they were right across the parking lot. So they were geographically desirable and close to the engineering team. So we decided to use this hotel. And the deal we had with them is that they would allow us to document the data and collect the data, but that they would not fix the issues unless it was a real extreme event, so that we could gather data on the leaks that were occurring and the types of leaks, how many corrected themselves automatically, and things like that. So in this instance, you're not going to see a lot of corrective action taken, but you will see the extent of the water waste that's going on just in this one property in just the first 30 days when we put our nodes in. So within 30 days of the 108 toilets, 27 toilets were leaking at a total of 2,400 gallons a day. 19 were from the phantom flush leaking, typical leaking flapper. 7 were both the fill valve and the flapper were leaking at the same rate, causing equilibrium. And then we had 1 with the faulty fill valve. We had 16 toilets that were caused 83 running toilets events within 30 days. And one of the things that was interesting is our first running toilet, we went over and fixed. This hotel did not rent that room for 4 days. So if we hadn't fixed it, the toilet would have wasted, it was running at about 7,000 gallons a day. So it would have wasted 28,000 gallons of water and cost the hotel an extra $350, just that one incident because of the increased water used. So over the 30 days, they lost almost 108,000 gallons due to leaking toilets and running toilets. And then on top of that, we fixed about 40,000 gallons worth of problems. One other interesting thing that we found through this technology is a lot of folks have gone in and put in low flow toilets that optimize at 1.28 or 1.6 gallons per flush. What we're finding is a lot of times the fill valve isn't set properly so that they're actually flushing at half a gallon or a full gallon, sometimes more, above that 1.6 gallon per flush or 1.28 gallon per flush optimization. So in this case, almost a third of the toilets were set improperly so that they were flushing at least half a gallon more than the specification on the toilet. We also found almost an equal number were flushing at less than the optimized gallon, which then puts them at risk for toilet overflows and clogs. The other thing we find is then you also get double and triple flushes, which then just wastes a whole lot more water. So the financial impact for this first 30 days is, identifying the cost of their leaking toilets is at their rate that they pay, which is $16.30 per 1,000 gallons, is about almost $1,200 in that 30 days. The cost of the running toilets was similar, almost $2,000 or $1,756. There was another savings that we added from the corrective action that our personnel took of $652. So from wasting water through their toilets, they were spending $35, almost $3,400. And it's interesting that their toilet leaks, running toilets, and overflows were costing them more money than all the other water usage combined in that hotel for the month. So it was even eye-opening for us just how impactful fixing leaking running toilets can be, both for saving water and for the bottom line of a property. So just to give you a sense of the return on investment, the nodes are $30 a piece. The gateway is $385. The subscription is $285 per toilet per month. So, the first year expense is about $6,600. And in this case, they would have had a positive ROI within 60 days. So we're not obviously that we're marketing on a 6-month positive ROI, which is still really, really quick. But, we're finding that a lot of properties actually get to positive ROI sooner. So, and we're getting a lot of interest, actually, even from the banking community, because as people fix their toilet issues, and that money drops to their bottom line and increases their net operating cost, which then increases the value of the entire property. So the bankers like it because it increases the value of their collateral. So in addition to the environmentalists and the green initiatives and just the plain business sense of wanting to control your costs, there's a lot of other interest in this technology for ancillary reasons. So that's us in a nutshell. I don't know if you want to ask questions or if we want to go to Ramzi and then ask questions at the end.
Let's hold questions if you don't mind, and let's go ahead to Ramzi. And then we have 15 minutes left, so I want to make sure we have enough time for Ramzi's presentation, and then we'll wrap them all together.
Okay, sounds good. Thank you, everyone.
Yeah. And Susan, do you want to stop screen sharing? Ramzi, do you have slides or no?
Yeah,
So, okay, so go ahead and you start screen sharing then.
Yeah. So, I will directly, could you see my screen?
Yes.
Yes, okay. So that I'm directly demoing our cloud platform based on our demo site. Just to give you an overview of the features, I will be very quick because, as I said, we have a solution that can retrofit or could be also built in water assets. It could be water treatment systems, sanitary ware, where we can actually monitor the water usage, but also the energy inside hot water, and then bring efficiency on water usage and efficient energy usage as well. So here we have this demo site. Actually, we have equipped my home with any endpoint. It could be a faucet, it could be a softener. We have also toilets and so on. So the idea here is just to you can quickly see the status of those assets, and here we switch on the devices tab, where actually it's the sensor level of our cloud solution, and each sensor or many sensors could be related to one asset. For example, we have here for a faucet one communication module related to two sensors who are plugged on the hot water and cold water at once with one communication module only. We call it the twin mode, and we have a mono version, which is, for example, connected to a toilet here. We have also retrofitted a softener. I can click on the asset and then I switch on the dashboard where you can see actually the consumption of this softener. My softener is plugged at the entry of my home. And then I have different kind of analytics. I can also know when I have to go to refill the salt of this softener, which is very useful for maintenance purposes. And we can also identify if the average flow rate is diverging and then bring alarms. Here I can go back to assets and show you actually that my home is quite digital now because we have every floor equipped with our solution. Now, if I go, for example, to toilet, you have here the status of our devices who communicates also with LoRa, like Susan. We have a gateway that actually can connect up to 100 devices at once, and which make the link with the devices and the cloud through Wi-Fi or GSM the same way. So I can go back here, for example, to the toilet ground floor, and I will see the different water consumption for these assets. We have even thought about the metrics in the US in gallon and Fahrenheit in order to ease the adoption abroad. And as you can see, we have the flow rate history. We are able actually to, with our algorithm, detect some diverging patterns of flow rate, which enable us to know if it's leaking, if it's over setup, so the setup can be fixed. And here you go on the modules with smart sanitation modules, and now we are actually developing different kind of analytics where we go beyond just measuring the water consumption. It's also about the affluence related to this asset. We know how many person when have used this asset. We are able to know if the people are using a toilet, if they are washing their hands afterward, and then compute a hygiene score of those people in public restrooms. Here we didn't activated this, but here you can see the today consumption versus average daily usage of the faucet, and the same for toilets actually. And what is very interesting is when you compare those assets between each other to determine the benchmark of each of them. So here you can see that this flush is consuming a lot of water, and you can drill down and see if it's related to a problem or just to because it's more used than the others. And when it becomes very interesting is this metrics gives you actually a benchmark related to all the toilets, and you can fix them to reduce the specification to be compliant with the specification of the toilet. We are also measuring the average hand wash duration to see if you are compliant, for example, with the sanitary, with the health measures that are today enforced with the pandemic. In Switzerland, it's at least 20 seconds of hand washing. So it's also a KPI that gives you a bit how you can better make aware the people about their hand washing practices. Finally, you have the profile of hand washes here, which is very interesting, is a lot of people are using a lot of hot water. We have normalized this view to be able to compare each hand wash with the others and see that actually faucet can be to reduce in order to reduce energy consumption. In Switzerland, you can say that cold water is 1 franc for 1 cubic meter of water, and hot water is 5 francs for 1 cubic meter. So it's 5 times the cost of cold water. So in Switzerland, we are very focused on how we can reduce energy consumption and energy waste related to water consumption. Now, the next step for us is actually to gather all the data of hot water consumption to be able to predict when you are going to use that hot water in a day or during a year, and then adapt the boiler to increase to go up or go down, basically to shut off or shut on the boiler to reduce energy consumption of the building related to your hot water demand pattern. That's all for me. Sorry if I was a bit too long.
No, that's great. Thank you so much, Ramzi.
You're welcome. I will, yes, sorry. I will stop sharing.
Yeah, then we can all be back in the same area.
It's here, yeah.
Yeah, well, with that, yeah. Let's open it up for some questions. Well, I have a question. Clear. I'll start with mine, and then others pipe in.
Yeah.
Actually, I have a question for you, Ramzi, about the ability to measure a variety of outcomes aside from water usage. Do you see that influencing? What actually came to mind right away was in the time of COVID, right? The importance of the public messaging of washing your hands. Yes. Have you seen have you been asked to measure, say, hygiene or quantify that based on our current pandemic?
Yes, we have deployed our solution in schools, actually, in Switzerland, where the manager of the school his need was to monitor how their students are washing their hands, because more absence for those students means probably the closing of that school. And then they would like to monitor and also use this tool as an educational tool to raise awareness around hands hygiene and so on for their students. And we have done that. We have measured the endpoints first without the feedback of a screen on premise, and then we have put the screen to bring the data to the students. And we have seen a huge change in terms of behavior, because the first months, actually the average score was around 6 out of 10. And after the screen, we have seen an average score around 8 or 9 out of 10. So they have seen clearly an impact with the feedback of the analytics on the behavior of their students. And that was very interesting.
Thank you.
You're welcome.
I would love to open it up for someone else to ask a question.
Ramzi, I have a follow-up question about COVID and biomonitoring. Do you actually monitor the waste, or do you only monitor the outflow of water?
Today we only monitor the outflow coming from water assets.
Right, because recent reports from a company called BioButton, they were able to measure the fecal matter and determine the spiking of COVID infections. I don't know if you heard about that. Yeah.
Yes. We have heard many companies now are very interested to monitor wastewater to identify how the viruses is spreading, and predict actually also how the virus is growing in the population. Our solution is more on the prevention side than on the detection side. And we see a great potential to raise awareness around hands washing, because it is a very important way to reduce the spreading of any viruses, actually, even flu, even other bacteria or viruses. And we actually neglect a bit this aspect of the hygiene today actually in many countries, even developed countries and developing countries.
John, can you say a little bit more about what you know about BioButton and how it relates to the MEMS technology that you were involved with? Was it monitoring similar parameters as?
Well, I'm not I don't, you know, I only know from press reports about BioButton, but I looked into it, you know, superficially, and it appears as though it may have some differential measurements between different biological substances. So you, at the nano level, you would have microfluidics and then be able to measure specific biohazards depending on the electronic differentials and that kind of thing. You have to look at bioluminescence and all that.
John, I'm going to interrupt you. We're closing out and being moved back in 5 seconds.
Well, I didn't have too much to say.
That's okay, and I'm sorry we didn't have more time for questions. I had some lined up for Susan as well. And actually, unless they're forcing us to go back over, maybe we.
You want to email them to me or whatever? You can. I can answer them later.
It looks like we're going to close out in a minute. Let me just ask you to round out with this, Susan. To changing public behavior, has your product been used maybe in any kind of LEED certified or buildings that are saying we're a green building in order to actively measure and change water usage to be better public actors?
We are in discussions with green buildings. It doesn't work on flushometers. So to the extent it's a tank toilet device. So for the large office buildings and things like that, most of those have flushometers. I am talking with EPA because I'm trying to get WaterSense to have a toilet leak detection category in which we can get WaterSense labels, and then it'll automatically qualify for LEED points, which then opens that up in a much easier way. But that's a process. So we're having